I'm Edwin Ritchie. I'm the extension soil specialist located here in Princeton. I was fortunate enough to take over Lloyd Murdoch's position when he left. So work a lot with Lloyd Murdoch, John Grove, my counterpart Josh McGrath back in Lexington. So what we're going to do here, we're going to move over and start looking at rows 5, 6, and 7, and we'll just kind of meander through and get to the end and then talk about it. So what we did, that row 5 is no-till. Row 6 is conventional till. Row 7 is conventional till that we took a grain truck and drove up and down here about 6 or 8 times. And then we planted into it. So, what else do you notice? Take the compaction out.
Well, did you change your seed rate for the no-till?
We didn't change the seed rate. Everything was the same. You might not notice it quite as much here. There's a little bit right behind you. Erosion. If you get to the end of the plots, it might not show it as much as it did. There's soil about 3 or 4 foot outside of the end of these 2 plots. All the other ones, the soil stayed in place. Don't think that there's not a whole lot of slope here. You wouldn't think you would lose a lot of soil. We can lose quite a bit of soil. Let's go down to these these probes that everyone noticed. This right here, one of the biggest problems is sometimes people will think, oh, I can detect the compaction with this. Yes, you can. Moisture greatly influences it. Right now, we're probably a little bit on the dry side to get a good measurement. You can get relative differences, but you might not get that critical absolute value. It says, oh, I need to do something at this point. There's a worksheet in there and there's a data sheet. Typically this is about a $200 machine. It's good to work in pairs. It's measured, has marks every 4 inches. So ideally you'd want to push it down with constant pressure, have someone looking at this, and then you're looking at the gauge. When it gets into, there's 2 different size tips. This is a 1/2 inch, this is a 3/4. I always use a 1/2 inch tip in a silt loam soil. So that means you're looking at the bottom ring. When it hits the red, you've reached 300 PSI. That's what a lot of people say is a critical value. If you're using the bigger tip, that 300 PSI is all the way over here instead of right here. So you would ideally want to see when you hit that red, okay, I hit it now. Someone should have been watching that, my partner, and then hopefully you'll get to a point that you push through. Guess what? I'm all the way down to, I don't know, 24 inches or so. I never pushed through. How much good am I going to do with the subsoil if I've never hit the bottom of the compacted layer? Probably not a whole lot, because you still have a restricted zone down there. Ideally, you'd be able to find some, we'll say at 8 inches, I push through at 16 inches, set my subsoiler for 18 inches, go on through it. So soil moisture is critical. You want this thing to detect differences in actual soil compaction, soil tightness, not a difference in soil moisture. I was out here yesterday, it was a little bit better. Probably the day before it would have been okay. Ideally, you want to run these when your soils are at about filled capacity. Filled capacity is, if you think about taking a sponge and you hold it up, you soak it, get it wet with water, hold it up by the corner. When that sponge quits draining, just holding it up, that's going to be about filled capacity. So when the water is not saturated, it's through draining, that's about the ideal time to run a penetrometer. Conversely, that's also about the most efficient time to cause compaction. So as soon as you can get over the field to do something about it, that's going to be when you are most able to cause compaction. I know a lot of people trying to get in the field with their planter. Oh, I've got a little turbo till or a big turbo till. It's 40 foot long, 40 foot wide, I mean. I'm going to run it across the field, dry it out. You are drying out that surface, but at that same time, you potentially are creating a bigger issue. So moisture status is critical for causing compaction. It's critical for identifying compaction. Winter, early spring, those are the best times to do something about it. So we're going to keep this, might even run over this again after we harvest a couple times. We're going to try to keep this in place and just maybe come out here and subsoil in places. But any questions or comments about this? I've got one more thought if not.
So how would you fix this?
Right now,
In a farming situation when you take all the weed off? Rip it?
that would be a good, that's probably the best approach for this.
Yeah.
In that field sheet, we have different, you're not looking, okay, I found one value out of 100 that's 350 PSI. Do I subsoil the whole field? Probably not. It's a percentage of those values that are over 300 PSI. I think Lloyd did the work and said if you're at 50% of the field, you're probably going to see a benefit from subsoiling. If you're at 75, I don't remember the number exactly, it's in that packet, most likely you're going to see a benefit. So if we identify this area right here as the only compacted zone, would I benefit subsoiling the whole field? Probably not. You would probably just want to address that traffic area. So, I mean, it's kind of like putting down fertilizer you don't need. You're burning diesel fuel that you don't need to. The number is 300 PSI, regardless. You can get by with a higher PSI on the no-till plot because you have those old macro pores. That was going to be my last point. I don't know, crops differ, but corn is, I think, more sensitive than wheat. I think soybean is even less sensitive than corn, or more sensitive than corn to a restrictive layer. But if they can find an old root channel, worm pore, something like that, those roots are going to be able to find their way through it. So I don't know the answer to your question, but generally you're going to be better off at this. If you're at 300 PSI in both these, more likely you're going to see less compaction, less expression of compaction in the no-till.